Hi, in this video we are going to study the problem solving and the algorithm design. Of course, we cannot let you master the programming skills in just one lecture, but we are going to let you know the general process of solving a problem by using the computer. So you're going to know the system development phases, and we're also going to study a top-down methodology to analyze the problem and develop an algorithm to solve the problem. We're going to study some tools like the pseudocode and the flowchart to describe an algorithm. We're also going to study some basics about the programming languages. So solving a problem is actually easy because we are actually solving problems every day. If I give you this simple problem to switch the content of two tapes, I think you will be able to solve this one. You can find out a step-by-step approach. So this is the problem solving. Or I want you to sort a list of numbers. You will also be able to figure out a way to solve these numbers. For example, you can search in the list and to see which one is the smallest one. You find the smallest one and put it in the front, and then you find the next one in the next. So this is your algorithm. And we can definitely define different approaches to solve this list. So solving a list in the computer science is actually a quite classical problem, and we can define different algorithms to solve the list. This one asks you to input a number n, and then you need to output a picture that includes n by n asterisk symbols. So if n equals to 5, you're supposed to print out this figure. And this is also an algorithm. How are you going to design an algorithm to ask the computer to print out this figure? So this is what we could do using the computer. All of these are simple problems, and it's actually not very difficult for us to get a solution. But what if the problems are very complicated or very huge, very large problems? In this case, we need several steps to simplify the problem-solving process. First of all, you need to understand the problem. Secondly, you need to design a plan. And then you can carry out the plan. And then you can look back to see whether the generated result is as what you expected. If the result is not good, you probably need to reanalyze the problem again, and then maybe to make a new plan and carry out the plan. So this is kind of like a loop. Here, let's do some questions that can help you to better understand the problem. First is, what do I know about the problem? So what is the information that I have to process in order to find the solution? So this is kind of like the input of the problem. So what does the solution looks like? You'll probably have a general idea. Maybe it's not quite clear, but this could be your initial solution. What sort of special cases exist? So this is quite important. For a problem, you probably have many special cases. So if your algorithm doesn't think about these special cases, your approach is not complete. It's not stable, probably. Lastly is, how will I recognize that I have found the solution? Because you need to evaluate, your design. These are the questions that you can ask yourself when you try to analyze a problem. One important thing for all of the programmers is to look for familiar things. I would say never reinvent the wheel. Most times it's correct, but sometimes it's not correct. For a regular programmer, whenever he wants to develop some algorithm or some software module, you probably can search online, because nowadays we can find plenty of open source programs. Maybe someone else has already developed those modules, so you don't really have to re-implement the module. So in this case, you can just leverage the open source modules or algorithms. But for some other programmers, maybe it's quite necessary to reinvent the wheel, like if some of the module or some of the software is not good enough, that you need to reinvent or redesign or re-implement the software or the module. So this part just let you to know that as an experienced programmer, it's very efficient and very important for them to find out the existing solutions. If the problem is a large problem, you can divide it into small problems or small units, and then you try to solve the small units. So we call it divide and conquer approach, which is frequently used in our daily lives. For example, you want to organize a party, so you want to order the food. So suppose this is a problem, and then you try to make a plan for this problem. Firstly, you need to ask yourself questions, and then you're looking for those familiar things, and then you can use the divide and conquer to simplify the problem. Questions will be like, where are the participants from? Because you want to find the location that not quite far from any of them. Secondly, can they eat spicy food, or is there any taboo? Thirdly, of course, you need to know the budget. Next one, is there any specials in the restaurant? If you know the specials, you can probably save some extra money. Second is look for familiar things. There are probably some common packages for birthday party. You can ask the waiter for help. Next is to use the divide and conquer. For a food ordering problem, you can divide it into different sections like the snack section, drink section, main dishes, dessert. And then you go into each of the small problem, which will be easier to solve. So after we study the problem solving general process and the divide and conquer approach to analyze your problem, let's look at the algorithm. So because we want to use a computer to solve the problem, an algorithm is an ordered set of unambiguous executable steps that defines a terminating process. Or it can also be defined as a set of unambiguous instructions for solving a problem or subproblem in a finite amount of time using a finite amount of data. So here shows you some keywords like the unambiguous executable steps or unambiguous instructions, meaning that all the instructions need to be clearly expressed. So what you need is just logic. The computer can execute the instructions step by step according to your logic. That's why I think making a program is not that difficult, because what you need is the logic. So we call this computational thinking. So it's a little bit different from the divergent thinking. The second important keyword here is that you need to make the algorithm to be finished in a finite amount of time. If your program is infinite, so that means the computer cannot stop. It will continuously be working on your problem. So when you design an algorithm, you need to think about this issue. Let's take this recipe as an example to see how to design an algorithm. So the name of the algorithm or the problem is called the Never Fail Blender Hollandaise. It needs some ingredients. So we could analyze the problem and we look at the process, and then we can make it step by step. So if we change it into an algorithm, it will look like this. So the first step is to put the butter in a pot and then turn on burner. You can see every step is quite clear. The third step is to put the pot on the burner. And then this step is different, it's a while not bubbling, you leave the pot on the burner. So this is like a loop. This is not just a one-step execution. So you have to wait until it's bubbling. Next step is to put other ingredients in the blender. And then you turn on the blender. While you have more butter, you keep pouring butter into blender in slow stream. So this is also a loop. So keep doing this until all of the butter are put into the blender. The last step is to turn off the blender. So this is a pretty good algorithm. So you see, it's easy to analyze the problem, and it's also easy to design the steps. So the computer problem solving process is look like this. First of all, you analyze and specify the phases. Secondly, you design the algorithm, and then you implement the algorithms, and then you maintain the program. And we call it software engineering process. So actually, software engineering is another course in the computer science major. In that course, you're going to learn how to develop softwares, how to specify the requirements, how to design the solution, how to design the algorithm, and how to implement the algorithm, and what you need to do in the maintenance phase. So this shows you the relationship between the different steps. You could see many backward arrows here, meaning that you can have several loops. So you first define the requirements, and then after you finish the software development, you probably need to go back to the specification again, because maybe some of your requirements are probably not accurate. You probably need to reanalyze the problem and then to develop the plan again and to re-implement some of the modules of your software. So we mainly have the problem solving phase and the implementation phase. So in the problem solving phase, you analyze, make the general solution, and then you test your solution. If everything is okay, you go to the implementation phase. If your general solution is not quite perfect, you probably need to reanalyze your problem. And during the implementation, maybe you also need to go back to the problem solving phase. In the development phase, you probably could use two methodologies to design your solution. The first one is the top-down design. The second one is the object-oriented design. Both of the methodology are already used in the software development. The top-down design is just like the divide and conquer. So you break the problem into a set of sub-problems, and we call each of it a module. And then you create a hierarchical structure of the problems and the sub-problems. So this is quite similar as the divide and conquer. So you have the main problem, and then you can divide it into two separate modules. The first one is called the invite people, second one is called the prepare food. For the invite people module, you also need to make a list, and then you can call the people. So this is a small module. So in this case, the main problem is called invite people and prepare the food can be divided into three actually sub-modules. And then we can try to design the solution for each of the module. So this process could continue as many as possible levels until each of the module are small enough to design the solution. And if the modules need to be more explained, it's called abstract step. It's not a concrete step. The lower level modules are concrete steps, and the upper level modules are abstract steps. So if you need to design an electronic toll collection system, and then you can divide it into 4 subsystems like the toll tag, tag reader, video enforcement, clearinghouse processing. For the video enforcement, we can also divide it into subsystems until the bottom level, user interface, I/O card, enforcement software, video controller. So this is the top-down design. So of course, your algorithm must be tested, because testing your algorithm is the crucial step to make your software more stable. You could have the desk checking, meaning that you can work through the design at the desk with pencil and paper. And second is the walkthrough, so you can manually simulate your design, by the team members taking sample data values and simulate the design and using the sample data. You can also use the inspection. You can ask another one to read your design and try to figure out which part of your design is not proper. In the program maintenance phase, the purpose is to ensure that the current program are operating error-free, efficiently, and effectively. Actually, more than 75% of the total lifetime cost for an application program is for the maintenance. So it's quite time consuming and quite important for the maintenance part.